Okay, let's continue with our skills check exercise number 3. Okay, so for our solution, again, you want to be able to solve for y here. Okay, so what you can do is you can bring this 6 over to the other side, to the left hand side. It's going to be x minus 6 equals negative cube root of y minus 3. Okay, now I'm going to just switch it around to take y to the left hand side of the equation. So when I do that, I'm going to get, now y is going to, the cube root y minus 3 is going to be positive, equals my x is going to be negative, because I'm taking this this 6 to this side right here and this x to this side of the equation side. So my x now becomes negative and I have a positive 6. Okay, so what's going to happen, I'm just going to rewrite this now and say the cube root of y minus 3 equals negative x plus 6. Okay, all I've done is just rewrite it. Okay, so when I do that, I want to be able to, I want to get rid of this cube root, so I'm going to multiply by the exponent 3, right? So it's going to look something like this. That's the cube root y minus 3, and I'm going to multiply that by power of 3. And whatever I do to the left hand side, I got to do to the right hand side. It's going to be negative x plus 6. Okay, so now I'm left with, these two cancel out each other, so I'm left with y minus 3 equals negative x plus 6 to the cubed. Okay, and I want to solve for y, so y equals negative x plus 6 to the cubed, and I just bring this 3 over, negative 3, to the right hand side of the equation, making that equal to a positive 3. Okay, so that's typically the answer right there. Okay, let me do that correctly. That's going to be your answer right here. Okay, so let's move on to another problem. We're looking at number 1. Look at number 1 here. We're looking at number, I'm going to do number 2. I'm going to do number 3 for you, and I'll do number 9. Okay, those 4 problems. So here, we can, for the first one, this is number 1, and they want us to determine if if each function is a 1-to-1. Okay, so the definition of a 1-to-1 typically is your f of a does not equal f of b. Okay, and another way to look at this, if you do the horizontal test, if your horizontal line passes through 2 points on that particular graph, it's not a 1-to-1 function. Okay, so for number 1, we have here our f of x equals 3x minus 1. So the best way to really plot this real quickly is, this is in the, what we call the slope intercept form. Okay, while this negative 1 is your y-intercept. So that's a negative 1. This is negative 1 here on the y-axis, and I have a slope here of 3, right? And remember, our slope equals rise over run, and the rise is going to be 3 and the run is 1. Okay, so what we can do now is we can go 1, 2, 3 up 1, okay? And we can go over, so once you can do it that way. So the rise, rise is 3, is 1, 2, 3 over 1. Oops. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And then you can draw your line like this. Okay. So that's your 3x minus 1. Okay. Okay, you could just use that technique, or if you want to be able to plot using x and y and choose your values, you could do that as well. But that would take a longer time. Okay. So we draw horizontal lines. In this case, I'm going to choose a different color. As you can see, if I draw my horizontal line, the horizontal line only crosses this graph only one time. Only one time. Only one time. So this is, number one, is a one-to-one function. So the function is one-to-one. Okay. I just put one-to-one. Yes. Okay. Number two, I'm just going to do this very, we know that our function f of x equals 2x squared. Okay. So you know it's going to be a parabola, right? Due to this x squared. So it's going to look, something like this. Okay. That's just the profile. Okay. So I didn't plot any points there because you just know it's just going to be twice 2x. Twice x squared. Okay. So, but you can plot it, and then you'll see the profile looks like that. But either way, when you um, want to perform the horizontal test, you can see that this horizontal line passes through two points along this graph right here. Okay, another line, it passes through 2 points right here. So this is not a one-to-one. Okay. All right. Let's go to the next problem. We said we're going to do um, 3 and 9. Okay. So for our 3, number 3 here, I'm only going to be choosing values that are actually greater than 1 due to this stipulation right here. Only values um, greater than equal to 1. Okay, so whenever you have, for number 3, you have your f of x equals your x minus 1 squared. Okay, so you know automatically that um, your basic function is going to look like this, a parabola. Okay, but it's being shifted over to the right by 1 because you want to ask yourself, in this parentheses is shifted horizontally to the right by 1. What's going to make this value go to 0? And that's a positive 1, right? Positive 1 minus 1 gives me 0. So it shifts. Okay, so it shifts over. It shifts over by 1. Oops. Okay. It shifts over by 1 like that. Okay. And now, but we only want values greater than 1. So this would disappear right there. Okay. Now, when you perform your horizontal test, you can see for every horizontal line is only just crossing at 1 point. So the answer to this one is yes. It is a one-to-one function. Okay. And then number 9, f of x. Okay. f of x equals x plus 1 cubed minus 2. Okay, so in doing so, again, you can look at the basic function. It's going to look something like this. Okay, and this is going to be f of x equals x cubed. So now we have to be able to move this to the left because we look at this first. Okay, we look at this first, and you want to be able to ask yourself, um, what number do I have to put in this parenthesis to make this parenthesis go to 0? That's going to be a negative 1, right? So I'm going to move this over by 1. Okay, and when you do that, now I'm going to come down vertically by negative 2. So if I were to go back again and move this, 1, 2, that's where it should be. And you draw a horizontal line now. You notice that this horizontal line only crosses one point along this graph. So to answer your question for this one, it's going to be a 1-to-1 ratio, 1-to-1 ratio. I mean 1-to-1 function, I'm sorry. So the answer is yes here. Okay. Okay, let's move along. I'm going to go and do number 11. So for number 11, okay, let me stop here and I'll come back. I'll come back to this particular problem in the next video because I'm trying to keep these videos as short as I possibly can. Thank you very much. Okay.